Good day, everyone. Today, let's explore the concepts of measures of variability and kurtosis, focusing on the idea rather than the calculations. These are the objectives. So, what is the measure of variability? Measures of variability or dispersion indicates how much the scores spread out from the mean. This means measures of variability like range, variance, and standard deviation shows how much individual scores deviate from the average or mean. It indicates degree of spread or dispersion in a data set. For the measures of variability, first of all, we have the so-called range. Range is the difference between the highest score and subtracted by the lowest score. A reminder for this lesson that we do not include the calculations at all, only the ideas or concepts. For the range, let's have an example. From the class test score, the scores ranges from 10 to 50. The range would be the difference between highest score 50 and lowest score 10. As you can imagine, this shows the spread of data. Since the range is dependent only on the low and high scores, it is often unstable and is useful only for gross ballpark estimates of variability. When we say ballpark, it means it's not the exact value but close in a number or amount. Next is the variance. Variance is a measure of dispersion across a data set, comparing the difference between every other number in the set. Consider two datasets with the same mean of 36. Dataset A is said to have a smaller variance because the scores have a smaller interval from the mean, indicating consistency. In contrast, dataset B has a higher variance due to the larger intervals from the mean, showing inconsistency. This suggests that Class A has a consistent scores with smaller variance, while Class B has varying scores with higher variance, indicating differences in students' performance. For the last, we have standard deviation, a statistic that measures the dispersion of a dataset relative to its mean and is calculated as the square root of variance. The standard deviation is a number that indicates the average deviation of the scores from the mean. For example, the average of the class is 90 but some of the students got scores of 85 and others got scores of 95 that indicates small standard deviation. This indicates a relatively small standard deviation because the scores 85 and 95 are only 5 points away from the mean 90. The deviation from the mean are not extreme, suggesting that the scores are relatively consistent and clustered around the mean. Now we will proceed to the next, the kurtosis, a statistical measure used to describe the distribution of the observed data around the mean. This tells us whether the data distribution is heavy-tailed or light-tailed in a normal distribution. Kurtosis tells us the peakedness or flatness of the distribution. Kurtosis is basically a statistical measure that helps to identify the data around the mean. For the kurtosis, we have three different types of kurtosis: the leptokurtic, mesokurtic, and platykurtic. Leptokurtic or high kurtosis. This type of kurtosis have very long tails, which means there are more chances of outliers. This type of kurtosis indicates a distribution where more of the numbers are located in the tails of the distribution instead of around the mean. For example, most students of the class scored exactly the same, with a few outliers scoring extremely high or low. The distribution have fat tails with the mean of 77.5. For the scores, we have 680s, 120 and 20. This dataset illustrates a distribution with a high concentration of identical scores and extreme outliers resulting in fat tails. For the second type, we have the mesokurtic or the normal kurtosis. Mesokurtic is the same as the normal distribution, which means kurtosis is near zero. In mesokurtic, the distribution and its curve is in the medium peak height. For example, a class where most of the students' scores are very close to the average while few of them get high or low scores. For the scores, we have 38, 36, 35, 37, 36, and 34, with a mean of 36. This dataset illustrates a distribution where most scores clustered around the average, with a few outliers on either end. For the last, we have the platykurtic or the low kurtosis. Compared to the normal distribution, these kurtoses have the flattest peak and highly dispersed. The platykurtic have a lower tail and stretched around center tails means most of the data points are present in high proximity with the mean. For example, in a class scores are spread out evenly across a wide range with no extreme scores. The distribution is flat. So we have the dataset of 20, 30, 40, 50, 60, 70, 80, 90, and 100. In this dataset, scores are spread out evenly across a wide range of 20 and 100. So there are no extreme scores or outliers. The distribution is relatively flat with each course having a similar frequency. In this case, each course appears only once. This type of distribution is known as a uniform distribution. So now let's talk if the levels of measurement is applicable in measures of variability. In levels of measurements, we have nominal, ordinal, interval, and ratio. In measures of variability, we have the range, variance, and standard deviation. First is nominal. In nominal, you can only count frequencies in categories. Arithmetic operations like subtraction or calculating distance from a mean are meaningless. Next is ordinal. Here, you can calculate the range for ordinal by finding the difference between the highest and lowest rank. The third one is the interval. Interval data allows for calculation of standard deviation and variance because the equal intervals between values make addition and subtraction mathematically valid. For the last is ratio. Ratio data allows for all arithmetic operations and enables calculation of the coefficient of variation, facilitating comparison of variability between datasets with different means. Let's now move to the relationship between measures of variability and measures of central tendency. Measures of central tendency, we have the mean, median, and mode describes only the center or typical value in a data set, while measures of variability shows how spread out of data is around the center. So let's now move to the next. the importance of measures of variability and kurtosis in the field of education. First, we have understanding the student's performance. Kurtosis and variability measures helps educators to understand how student scores are spread out and identify unusual patterns or outliers, informing instruction and support. Next, making informed decisions. Understanding kurtosis and variability enables educators to make informed decisions on teaching strategies, assessments, and support, ultimately enhancing students' learning and outcomes. For the last, we have assessment evaluation. By analyzing kurtosis and variability, educators can evaluate assessment effectiveness, identify score patterns, and determine if assessments are too easy or hard, ultimately measuring students' knowledge levels and informing instruction. As our discussion ends, always remember that in measures of variability, if the scores are bunched together close to the mean, then there is a little or small amount of variability. A large or great amount of variability is a characteristic of distribution in which the scores are spread way out from the mean. And in kurtosis, the tailedness of distribution tells you about the frequency of extreme values or outliers. In kurtosis, also focus on tails, not just the peak. Because in educational setting, leptokurtic can be a dangerous result as it indicates extremely high or low scores. While platykurtic, the result has lower probability of extreme high or low scores. And in mesokurtic, this indicates the normal curve. This result has fewer high or low scores. This ends our discussion for today. Good day everyone and thank you so much.